Hello everyone, we're Team 23 and we are excited to share our halftime progress on Shakespeare, the emergency response app that calls for help when you cannot. Let me quickly introduce our purpose. Imagine being trapped in a wrecked car, arms pinned, screen shattered, or hiding during an assault, unable to dive, or collapsing from a seizure, your phone just out of reach. In these emergency situations, victims often cannot physically operate a phone due to injury, panic, or environmental constraints. For those situations that someone needs emergency help but cannot dial, our apps fix that. Shakespeare leveraging accelerometer-driven interaction to trigger emergency calls passively, aligning with Visor's vision of invisible interfaces for critical moments. One intentional shake would trigger an emergency call while automatically sending photos, location, and sensor-fused contacts to responders. And now I will walk you through our beta test plan to turn Shakespeare from an idea into a functional emergency tool. With structured development in clear phases, and with built-in flexibility to adapt as we learn. Here's how we are tackling it and where we are headed next. So in phase 1, it is the phase for laying the foundation. What we did includes holding brainstorming sections to flag challenges like gesture insensitivities and define deliverables. We also did some documentations like finalizing the proposals and embedding the Gantt chart. We designed a logo and created the GitHub repo. We also built a bare-bones demo to test the water. In phase 2, we implement the gesture detection feature, which is the heart of the app, and we leverage the coursework on signal processing to filter noise from raw accelerometer data. And we link the detection logic to the app backend. In phase 3, we finished the situational awareness feature and the UI. We implement video recording and GPS features. The UI features a main page with an emergency button, events list, and navigation, which includes settings and development mode. While backend service monitor sensor data and trigger emergency events like collecting GPS and accelerations when thresholds are met. And here is what we are going to do next. In phase 4, we will do the integration work. We will merge gesture detections with GPS and emergency call system, and we will optimize overall app performance. During phase 5, we will conduct testing and delivery, includes beta tester feedback validations, perform test cases to ensure a false alert rate below 5%, and finalize the user documentations.
This slide shows the preliminary results of the Shakespeare app, a lightweight Java-based Android app designed for emergency response through sensor fusion. On the left here, you can see the core functionalities we've implemented so far. The app supports video and GPS data capture triggered by button clicks, as well as gesture controlled, and automatically saves these with timestamps to a centralized file repository on the device. We've also integrated auditory beeps and vibration alerts to give users haptic tactile feedback when actions like emergency gestures are triggered, ensuring clarity even in high-stress environments. On the right, we show the working interface, the main dashboard with simple user-triggered controls and the resulting files. GPS logs, map images with an icon depicting the latitude and longitude at which the emergency occurred, and if there are more than one latitude and longitude data points, you will see a trajectory being painted on the map interface as well. Alongside, you have the raw GPS log data as well as video files taken from the camera as well. These are all saved to the device storage for later review or transmission. Ultimately, this app forms the foundation of a gesture-activated emergency logging system, enabling users to seamlessly capture and store critical context during an emergency, all with minimal input.
I'm here to demonstrate our Shake and Call feature. This function lets you quickly dial an emergency number by shaking your phone for a few seconds. It's good for emergencies when you can't manually dial a phone. This is how to use it. Open the app and tap the Start Shake Detection button. This activates a service that uses your phone sensors to detect shaking. And shake your phone hard for about 3 seconds. This app will automatically dial a preset emergency number. You see? So currently the number is just a test number for this demo. Well,
from the main page of Shakespell, you'll be able to see if the application is currently monitoring or not monitoring. And also on that page, you'll see a list of recent emergency events. Each event will have the date and the time, the location, as well as information saying if it has video recording associated with it, an image recording, or an audio recording. From the list of emergency events, you can select an event and then be took into an emergency detail page, which will provide the image of the location on a map, as well as some of the same information you saw prior, such as location name, as well as the date time, but it'll also additionally have the number that was dialed, as well as corresponding buttons, so that you can see the audio file, the photo file, or the video recording. As well, there's also a permissions page. You're going to be able to turn off some of these background permissions, or the permissions to turn off what will be captured during monitoring, such as camera, GPS, or your microphone. As well as there's also a dev mode. In the dev mode, you'll be able to access some of the raw data that was used, such as barometer data, accelerometer data, as well as GPS data.
This slide outlines the expected impact of our app, essentially as we move from a concept to a context-aware emergency response system. So from shake to safety. So on the left, our goal is to develop a production-ready Android app built in Java, which fuses multiple sensors to detect emergencies. We aim for the system to be more context-aware so that it understands the difference between casual movement and actual distress and responds accordingly. In the center, we showcase how we will formulate our target benchmarks for our performance. We aim to achieve fewer than 5% false positives from routine motion like walking or jogging, and under 2% false negatives during actual emergencies. Our goal is a reaction time of less than 2 seconds from gesture to emergency call and data logging. These metrics will then be validated through shake-based testing across at least 50 real-world scenarios. Finally, we're working towards a comprehensive ubiquitous computing framework that is completed with technical documentation and holistic testing on reducing sensor noise and ensuring energy-efficient always-on sensing. Ultimately, we hope this system can serve not just as a proof of concept, but as a platform others can build upon for responsive real-time emergency detection.
Right now, there are still some challenges. We are solving false positives. The app can be overly sensitive, mistaking some normal movements like walking for shaking. We are fine-tuning it to trigger only when you mean it to trigger. The second problem is the background operation. The feature is designed to work even when the app is closed, but some phones shut down the services in the background. We are working on a fix to keep it running in the background.